Assalamu alaikum. My name is Al and today we are going into the basics of microcontrollers and embedded systems. Today our topic is Introduction to Computing, Chapter 0. So let's start with the topics we are going to learn about. The first one is internal organization of computers, in which we have the different parts of a computer like input, output, memory, CPU. And next we have connecting the different parts, that is memory to CPU and input output to the CPU. And next we are going to learn about how computers work. So the input devices consist of, for example, keyboard, mouse, sensors, etc. And the output contains of LCD printers or a robotic arm. Then we have memory. A memory is, we can define memory as something that retains data or information that is written to it or embedded into it. Like if we talk about hard drives, there is data stored in it, so it is a storage device or a memory device. Paper, if we write something on the paper retains the data, so it is also known as a memory device. But here we are going to learn about CPU. So in CPU we have hard drives, SSDs, RAM, ROMs. These are known as the memory. Next we have memory characteristics. First of all, we talk about the capacity. When we talk about the capacity of memory, here we can say that when we say we have a 1 TB drive in our computer or a laptop or 256 GB SSD, that is the capacity of the memory we are talking about. That GB, MB, KB, TB, that defines the capacity. Organization, how the locations are organized. For example, a 128 cross 4 MB has 128 locations for each bit data. Okay. Access time. Access time is how long it takes to get data from the memory. So if we call a function to access the data from the memory, the time it takes is known as the access time. The memory are of semiconductors and non-semiconductors. The semiconductor memories are ROM and RAM. In ROM we have different categories like mask ROM, PROM. PROM is known as programmable ROM, EPROM, erasable ROM, EEPROM, electronic erasable ROM, flash EPROM. In RAM, we have static RAM, dynamic RAM, and non-volatile RAM. A mask RAM is only programmed by the IC manufacturer. The PROM is one-time programmable that can either be programmed by the IC manufacturer or someone who uses it. The EPROM is a shine ultraviolet. If we shine ultraviolet radiation on it, we can erase the data from it. So it's not a one time. If we embed a code into it, we can use UV light radiation to erase it. Then it can be rewritten again. The erasing takes up to 20 minutes. The entire contents of ROM are erased. Here we have different ROMs 2716 that has a capacity of 16K and 2K into 8 and 250 nanosecond access time is 24 pins. The voltage required to run is 25 volts. The EEPROM erase electrically. It uses electric signals to erase the data from the ROM. It also have different parts we can see here. 2816A25 that has a capacity of 16K. Organization has 2K into 8. Speed is 250 nanosecond, that is the access speed. Pins we have are 24 and the VBB is only required 5 volt. So it's better, we can say that the EEPROM is better than the EEPROM. Then we have the flash ROM. In the flash ROM, the data is erased in a flash, like you have a drive and you flash like in a blink of second and all the data is erased. That is known as flash ROM. The entire device is erased at once. In that we have 28F256-20 that has a capacity of 256K, organization 32K into 8, and the access time we have 200 nanoseconds with 32 pins and VPP 12 volt CMOS. Then we have SRAM. When we talk about the RAMs, they are made up of flip-flops, transistors. Advantages of it is it is faster and no need for refreshing. RAM is also known as a non-volatile memory or a temporary memory. So RAM stores data, and when we switch off the computer, it raises everything. So it's a temporary memory, so it's faster and no need for refreshing. Disadvantages is high power consumption and expensive. RAMs are expensive. The RAMs that are made up of capacitors, they use less power consumption, cheaper, and high capacity. Disadvantages are they are slower and refresh is needed. The NVRAM non-volatile RAM is made of SRAM battery control circuitry. Advantages: very fast, infinite program and erase cycle, and non-volatile. It means that they have temporary data, they are fast, and they can be erased continuously. So infinite program erase cycle. Disadvantages: the only disadvantages have it is expensive. The internal parts of computer CPU tasks. It should execute instruction. It should recall the instructions one after another and execute them. The memory pinout, here we can see the memory pinout D0 to D7. That is the connecting memory. The you can say the data lines, the data buses. Here we have the WE, OE, and CS. So the dash on it means that it is falling edge triggered. It means it is enabled by when the input is 0. When it's 1, it's on. Then we have the ground and VCC here. The CPU, we connect the different memory to a CPU and it controls it. Writing to the memory, we have address, control signal, data, and write enable. So the address here, then the falling edge, the control signal is given the data here, and then we can write it the data setup and the data hold, and it's the time taken to do it all. Then we have reading from the memory. If we are reading, then we send a control signal, the addresses of it is used, and the data is then fetched from that address and showed to the user. Connected IOs to the CPU: keyboard, mouse, sound card, graphic card, network card. You see this usually in your computers. When if you open your CPUs, you will see different cards embedded in them or connected to them. Mostly they are separable, like the graphic card and the sound card and the network card. They are separable. They can be separated from the motherboard. They are not, the chips are not embedded on the motherboard itself. CPU should have lots of pins. Here we can see the address bus, the data bus, and the control bus where we can read or write. The IO0, IO1, IO2, ION, it answers the input output pins. And here we have CPU, and all are these are the buses that control the flow of it. If we connect the memory to a CPU, here this is how it's going to look. The input signals, the memory, and this is a CPU. The same thing, just inverted. So how do we manage it? How do we send signals, and how the computer know where to save it and where to fetch it from? So we are going to learn about it now. Connected IOs and memory to CPU using bus peripheral IO. The logic circuit enables CS when address is between 0 and 15. Read or write about it. How do we make the logic circuit? Answer to it is write the bus address range in the binary. From address 0 to address 15, we have the binary code. For 0 is 0000, and for 15 we have is 000111, like 4 ones in a row. Separate the fixed part of the address and use a NAND. Design a logic circuit whose output activates when the fixed address is given to it. So here they have used a NAND that is used for the control signal. The example for address decoder. Design an address decoder for address of 300H 3FFH. The H displays the address. Solution: write the address range in binary. The 300 is used as 0011000000, and the 3FF is 00111111. So separate the fixed part of the address, where we can see the 0011 and the 0011, they are fixed. Design the logic circuit. So here this is the NAND gate that is used for the control signals. An easy way of designing, you can see that the 1 1 is here to 1 1 1 come here, the 0 0 come here, the 0 0 come here. So if we so to make the 0 1, we can use a NOT here, and they will convert it to 1. So to make it all 1 1, so the NAND can work. You see. Then what is inside the CPU? Inside the CPU we have a PC that is known as program counter. Then we have the registers, the instruction decoder, and the ALU. ALU is known as the arithmetic logic unit that does the arithmetical equations and solves it and gives the answer. How computers work. So now we have here address different. We have you can say the code that is to be run by it. So we started from the 0. The address bus is 0. We see what is on the 0. It has 31H. So the instruction decoder gets 31 from there, data bus to the instruction decoder. Okay. Then we go to address number 1. So now we use the input output pin 17, and if we give the input output 17 a value of 9, and here we can see that the 17 pin goes to A. The 17 pin goes to A, so it shows that if we give a value of 9 here, it will be given to A to store. So you can see that the 9, the data bus goes and it writes itself at the A. Then the next part is A is given to B. So the data at A is duplicated or copied to B. So B will have the 9 then. Yeah, you can see that the B has duplicated and make the copy of the value from A. Now the address bus 2 is running and the instruction decoder gets 26 here, and so it goes on. So if we go to the address bus 6, we have 5H. So this here shows that we have to go to the address 6. In the address 6 we have stored 5. So the data written at A will be overwritten by 5. First is what the stored value was 9, now it is overwritten by 5. So now A has 5. And then the next instruction that is given to the computer is to A plus B and store it in A. So if we add up A plus B, we have 9 plus 5, and that accumulates to 14, and then it is stored at A. So now A has a value of 14, and if we turn it into the hexadecimal, then the 14 is equal to E. So now the A will have a value of E. So here now you can see that the A has a value of E and the B has a value of 9. Next instruction given is that A is given to 7 address number. So we can see here that 7 is empty. So the solution of A plus B that is stored in A is then given to 7 to store. Now you can see that the 7 has the stored value of E, that is A plus B. Now we go on to how the instruction decoder works. Opcode, operand. So we give the instruction, they are read by the computer. We translate we work in a natural language, that is a C++, the coding language that we understand. The instruction is then converted into assembly language which the computers understand, and into binary language 0 and 1s. So the computer works in binary language and we work in like human languages that we can understand. So here are a set of instruction that is human, and then it is given to the computer and the memory transforms it into binary to understand it, and then it is solved. Now we have two methods. We have a Harvard architecture and the von Neumann architecture. So we in our general PCs use a Harvard architecture in which the data memory and the code memory have separated buses. But in the von Neumann architecture, the CPU, the code memory and the data memory have the same buses linked with each other. That's the difference between Harvard architecture and von Neumann architecture. So as we go on in learning about microcontrollers and embedded systems, here is our chapter number 1, Introduction to AVR. AVR, also known as automatic voltage regulators. The topics we are going to learn about here are microcontrollers versus microprocessors, most common microcontrollers, AVR features and AVR members. So what is the difference between a general processors versus microcontrollers? So we see that microprocessors are used in our daily use computers. They are embedded on the motherboard. We can see that they are used as a general purpose. They can be used for gaming, they can be used for office work, they can be used for editing videos and pictures. Some major companies that produce processors are Intel, AMD, Nvidia, etc. Now we come to microcontrollers. The microcontrollers are a smaller version of microprocessors that are not very generic. They are made for specific use, and all the components required for it are embedded on the board of microcontrollers itself. So we don't have to separately attach to them. In microprocessors, they are embedded on the motherboard, and on the motherboard we attach different peripherals and different things required to the motherboard, and they are separatable and they can be upgraded after time. So most common microcontrollers are 8-bit microcontrollers that are produced by AVR, PIC, HCS12, 8051. These are the different companies that produce them. And the 32-bit microcontrollers, they are produced by ARM, AVR 32, PIC 32. Now here we see the AVR internal architecture. So here we see that the programmable ROM is connected to the CPU. We have RAM, EEPROM timers, interrupt unit ports, and other peripherals. Also, we have the oscillator that gives the pulses to the CPU, and they are all connected by buses. And now here is a Mega 328 with 28 pin. This is the same IC that is used in Arduino Uno. It has 28 pins. The 28 pins are used for different purposes. They can be for input, output, VCC, ground, PWM, different purposes. The AVR different groups. We have different groups in AVR like the classic, mega, tiny, and all these names are define a special purpose for them. The classic are the classic, the mega is a bigger version of the classic AVR, a tiny is the smaller version of classic AVR. A special purpose has are designed for special purposes, and Mega has new features like DMA, DSC, and crypto engine, etc. So some members of the classic family, you can see them right here. Now some members of the Mega family, and this is the PDIP IC, the TQFP. So they are the same IC, but they have different pins and different purposes. SOIC chips, as you can see, these chips are the same, but they have different purposes and they are different in sizes. The CBGA is commonly used for SMD. Now the some members of the tiny family, some members of the special purpose family. Now these are the products. If you talk about the ATX Mega 64A1, it has a flash of 64 like a memory allocation of 64, SRAM, 4 input output pins, 78, 16-bit timers, 8, 12-bit DAC 2 into 8, and analog operator 4. And the list is given to in front of you. Now let's get familiar with the AVR part numbers, like the AT Mega 128. What does it mean? So the AT at the start means Atmel. The company that produces it, Atmel. Mega is the family group that it belongs to. Like we have different family groups like Mega, Tiny, Classic, Special Purpose, etc. And the 128 defines the capacity of its flash, the memory it has, 128K. Here also we have the AT Tiny 44 and the AT90S 4433. Thank you very much.